Good morning, student. Myself Mukesh Kumar Tiwari from LPM Public School. Student, you know that yesterday we were talking about for how the cathode rays have been discovered and also the composition of the atom. You know that atom contains the three fundamental particles: electron, proton, and neutron. And then after we start that how the electron are discovered. Clear? So we consider that the discovery of cathode rays directly or indirectly correlated with the discovery of the cathode rays. Clear? Today I will discuss about the properties of the cathode rays and also the discovery of anode rays, that is the discovery of proton. So let's start. What is the property of cathode rays? Clear? The some important properties of cathode rays are mentioned here. I will explain all the or each properties by giving a suitable experiment. So let's start. The first point is cathode rays travel in a straight line. What is the first property? Cathode rays travel in a straight line. How will you explain this point? Clear? So for this, an activity has been performed to check out that the cathode ray travel in a straight line or not. So in the path of the cathode rays, there is a light paddle wheel are being kept, and it is earlier predicted that when this light paddle wheel will be when an opaque object, not light paddle wheel, when an opaque object is kept in the path of the cathode rays, then there will be a image we can see on the wall of the anode sides. Clear? So here we can see that the cathode rays are travel in a straight line, similarly just like as a sunlight, because we can see our image when we walk in sunlight. Clear? So this is the first point for the explanation of the cathode rays travel in straight line. Second point, cathode rays are composed of very minute particles. What do you mean by this point? Here it is given that cathode rays are composed of some minute particles. To check out this statement, the scientist performed an activity to show this. He just put a light paddle wheel in the path of the cathode rays, and earlier predicted that when this light paddle wheel will start to move, then it is clearly indicate that it has some particles or it composed of some minute particles. Clear? And when the experiment were performed, it was the same things as predicted. Clear? So the cathode rays can move, or it has also tendency to move for the light paddle wheel, and that's why we can say here that the cathode rays are composed of very minute particles. Clear? Third one, cathode rays reflected towards the positive plate when electrical field is applied. There are two types of field: electrical field as well as magnetic field. Clear? So electrical field is composed of two charges, that is the positive charge and negative charge. So there is two plate, positive plate as well as negative plate. Clear? So I will explain what the meaning of this point or this property. Clear? When the cathode rays is placed under the influence of the electric field, then it always deflected towards the positive plates. What do you mean here? It clearly indicates that the cathode rays are made up of negatively charged particles. Clear? So that's why it always deflected towards the positive plate. Understand? The fourth one is the cathode rays are made up of a large number of negative charged particles, and these negative charged particles is known as electron. Clear? And this is the clear verification of the point number 3. Clear? Cathode rays are made up of a large number of negatively charged particles. That is, here the cathode rays always reflected towards the positive plate when electric field is applied. Fifth point, cathode rays affect the photographic plate. So here, when the cathode rays have been discovered, then the scientists want to know that what type of property is shown by this cathode ray. So they are observed many points which are given here, and these are some special properties for the cathode rays. Clear? Now again I just want to repeat that the cathode rays discovered by Julius Plugger in 1859, then after the Michael Faraday, and so many scientists also performed the same activity to prove that the cathode rays originated when the electric current passed inside the gases which are enclosed in the discharge tube. Clear? So I just want to say you that after all, when the cathode rays are discovered, no one say about the electron. The name electron first of all given by the chemist name was J.J. Thomson. Clear? So the whole credit for the discovery of electron is given to the Thomson. He gave the some idea or the some experimental evidence for the electron, that is its mass, its charge, so on. Clear? So the credit are given for the discovery of electron is J.J. Thomson, and the cathode rays discovered by Julius Plugger, then after the Michael Faraday and William Crookes, so on. Clear? So in this way the electron have been discovered. Now let's speak, come on, the second fundamental particle which is known as proton. Clear? How the proton are discovered. So there are some points are mentioned already here. The proton, the discovery of proton is directly related with the discovery of anode rays. Clear? So first we have to know that how the scientists predicted that there is the presence of another kind of the fundamental particles, that is the proton, because you know already that three fundamental particles are present inside the atom: electron, proton and neutron. We are talking about for electron just before 2 minutes. Now we are talking about for anode rays, that is the proton. Clear? So let's come on, how to start this topic. Listen the things. You know, yesterday I already talked about for how the cathode rays are discovered. For the discovery of cathode rays, we just the Julius Plugger selected a discharge tube, and there are some gases are enclosed inside it, and then through metal rod which is known as cathode, anode, so on, and then connected with the high voltage source, and after reducing the pressure many more things are happen inside the discharge tube, and finally we get the cathode rays which are originated from cathode and falls on the walls of the anode. Clear? So let's come on, we have to talk about for the discovery of anode rays. Clear? How anode rays are discovered. This was the time of 1886. The scientist name was Goldstein. Clear? Who suggested that the presence of or existence of a new type of the particle inside the discharge tube. No one before any scientist suggested about this type of new particles earlier. Clear? So the name was Goldstein. He said in 1886 that there is another type of the particles or rays are also present when the cathode, when the electric current are passed inside the discharge tube, and this is the time or during the origination of the cathode rays, at the same time anode rays are also produced. This was the concept given by Goldstein in 1886. But the question arises here, how you say here that the anode rays are also produced inside the discharge tube? For this, Goldstein suggested a point, and that point are given here. Clear? You know that in the cathode rays discovery, we just taken the glass tube which is known as discharge tube, and then the two electrode, cathode as well as anode, and we connected these cathode and anode with a high voltage source. and then this is the vacuum pump, so on. But here the Goldstein some changes. He just placed a perforated cathode just before the cathode. Clear? This perforated cathode or the cathode which contains some minute holes to check out that the presence of anode rays. Clear? He said that when the current is passed inside this discharge tube, then no doubt the cathode rays will originate from the cathode side. We already know about this. But at the same time, the anode rays will also originate. Clear? And it will go towards the cathode side. Clear? So when the current is passed inside this, then the anode rays starts to travel from the anode to cathode. And he earlier predicted that from this hole only anode rays will pass. Clear? No cathode rays will go from here, because there are some holes are given, and when the anode rays will originate from this side, then it will pass from this hole, and these rays fall on just behind the wall of the cathode and produces some fluorescence or light. So this is the anode rays, and in this way the anode rays have been discovered by the Goldstein. Clear? And the credit for the discovery of the anode rays is given to the Goldstein, first of all. Clear? Now we talk about for here that what is the properties of the anode rays in my next video. Clear?